Welcome to the Inside Silverstone podcast, a business-focused podcast covering all things tech, engineering and innovation. Hosted by me, Chris Broome, a huge tech, motorsport and gaming fan, and also the owner of Longhurst, a firm of lifestyle financial planners and independent financial advisors located in Silverstone, Northamptonshire. This is a series of unscripted and unpolished conversations with leading business owners, thought leaders and high-tech talent where we discuss their experiences within the Silverstone business and motorsport region. We will also be asking them to share their knowledge, insight and their thoughts on the future just for you. If you're looking to learn more about the Silverstone high growth region and commercially connect with like-minded peers, you've definitely come to the right place. Welcome to Inside Silverstone. Welcome to the next edition of Inside Silverstone. My name is Chris Broome and I am your host. Today I am delighted to welcome to the show a new friend of ours by the name of Tobias Knichel.
Correct.
From Punch Flybrid, who's Managing Director of Punch Flybrid. Tobias, welcome to the show.
Thank you very much, Chris.
First of all, Tobias, apologies. Have I pronounced your surname correctly?
Perfect, yeah, no, it's all good.
We're all good. Right, as is always customary, as I always explain at the beginning of this show, Tobias, I'd love to quickly run through your CV, if that's okay, quick snapshot,
Sure.
So our dear listeners can understand the sort of journey you've been on to becoming the Managing Director of Punch Flybrid. So, education-wise, so sort of born and bred and raised in your homeland, your motherland, in the form of Germany, where you did and studied for a mechanical engineering degree and qualification from the University of Cooperative Education of...
In Heidenheim, yeah.
There we are.
Yeah.
Which you did from sort of 03 to 06. And then in 2006, you decided to leave Germany temporarily
Yes.
at that time to come to the UK to study at Cranfield University, where you did a qualification in engineering and management.
Yes, exactly.
Right?
Yeah, the plan was to only be here for 1 year, but it quickly changed.
There we are, and here you still are.
Yeah, 12 years later.
To the benefit of our wonderful business region and country. And so before I actually get on to the rest of your sort of career, so what happened after sort of 2007, why did you come to the UK for this specific Cranfield sort of qualification? Why didn't you stay in Germany for it? What was the sort of story behind that?
Yeah, well, I was working in motorsport in Germany, and Germany can be seen maybe as the homeland of the car, of automobile technology. Mercedes-Benz created the first car.
Yeah.
But really, the motorsport industry, the best place to have motorsport industry is in the UK, because here you have almost all of the Formula One teams and you have all the industry surrounding that.
Yeah.
And so when I was working in motorsport in Germany, I had a very good friend of mine who said to me, Tobias, you really should go and study in England. There's a special degree, it's called Motorsport Engineering and Management from the Cranfield University. And if you want to work in motorsport, I highly recommend that you do this, because there you will make connections that you can use for all your life. And yeah, when I looked into it, Cranfield University at the time had a steering committee, and the head of the steering committee was Jackie Stewart, and that was very impressive.
Yeah, it is.
Exactly.
Yeah.
And on the steering committee were a number of other really senior figures from the Formula One world, technical directors, and very impressive people. And for me, as a young person working in motorsport, it was very impressive. And so I decided to leave Germany, which I absolutely love. I absolutely love Germany. I have a lot of friends there that I dearly love. My family, obviously, but I decided to go to England because of the motorsport world. And here you have the Motorsport Valley, which is like Silicon Valley. Obviously, Silverstone Technology Cluster is another name for it. And yeah, that was really the reason for me to go.
And so that was for a year. So that was 06 to 07. And then, as you've said, you then stayed. And so from 07 to 14, you worked sort of for Flybrid Systems, a business called Flybrid Systems, where you sort of started off as an engineer and then sort of worked your way up the ladder, as it were, to become commercial manager. And then Flybrid Systems was bought out by Track, is that right?
Yeah.
In sort of 14, where you were a business development director.
Yeah.
And then in 2017, they were then...
So in 2017, I did another change. I was then commercial director and operations director. And then in the beginning of 2018, we got bought, or Flybrid got bought by the Punch Group.
Aha, fine, okay. And so, which obviously then brings us to present day, where you are now manager director of sort of Punch Flybrid. And as we were sort of talking off air, you were involved in that sort of merger and acquisition process. Is that right?
So yeah, exactly. At Tortrack, I was part of the executive team, and my responsibilities in the executive team was basically all our customer relationships. And as part of this, I was also very heavily involved in the M&A process to find the best way to get the technology into production. And we had identified that Tortrack itself has not the right tools to get the technology into production. You know, the factories and the links into the high volume manufacture. We were very good at advanced engineering, but we didn't have the element of the manufacturing part, and that was really what we needed to bring the technology into the next step. And so we're looking at possible partners that we could either sell a license to or sell Flybrid to, so that we can secure the future of the technology and get into production.
And so what is the technology? So we've got, from the website, an understanding a little bit about what you do. So Flywheel technology. So for those that are listening to this, whether they be like myself, who aren't necessarily in the industry, as it were, or for students potentially listening, you know, what is Flywheel technology?
Yes. So we believe that at some point in the future, every dynamically operated vehicle or machine will have some form of energy recovery system on it. Because, you know, at the moment, how we're operating, for example, a road car, it's very wasteful. We use some kind of fuel or energy source. It might be petrol or diesel, might be an electric vehicle. We use that to accelerate the car. But then when we are braking, we are just using the friction brakes to slow the vehicle down. And so the energy that we create or that we turn into kinetic energy into the vehicle, we just bleed away as heat on the brake disc. And so that's very, very inefficient to do. But any dynamically operated machine or vehicle, when they change their speed, for example, usually you require quite a high power. And so what we do is we create the most power-dense hybrid systems by using flywheel energy storage technology. So we store the energy in a high-speed flywheel instead of, for example, say a battery or a hydraulic accumulator. So our energy storage medium is a high-speed flywheel as kinetic energy.
Okay, and in relation to the sort of sectors and industries that you sort of help and support, presumably, again from what I read, this started off as a genesis within motorsport. So
absolutely,
presumably, and this is me guessing, sort of F1 or...
Yes. Yeah, absolutely. So Flybrid was founded by two engineers who used to work in Formula One racing, and in particular the engine development. And the rules in Formula One changed in December 2006. The FIA announced that from the 2009 season onwards, curves would be allowed in Formula One racing.
Yeah.
And the two guys who founded Flybrid, they worked for the Renault Formula One team, and they won the championship with Fernando Alonso in 2005 and 2006. But at the end of the 2006 season, the FIA decided, you know, there's a lot of money being spent in Formula One, and they want to target the spending into a certain direction. So they decided to freeze the engine rules for 10 years, and therefore introduce new things like hybrid systems. And because the engine rules got frozen for 10 years, this engine development department was completely fired. So my the two founders of Flybrid, they sat in the pub with a redundancy check, and they thought, okay, what do we do now? We know there will be a market coming up for hybrid systems. We think we can develop a solution for this, and so they decided to create Flybrid and to develop, as a first step, a hybrid system for Formula One. Our initial plan was to stay in motorsport for a number of years, but we actually got surprised by how quickly the other industries got interest in flywheel energy storage solutions as well. And so I joined as a second employee when we were just a startup business. We actually had an office. I think it's actually the one behind us now in the meeting room here in the
Innovation Center. Really?
Yeah, we had a little office, not bigger than this meeting room, where the two founders sitting in there, and then two employees. So I was employee number 2.
It's fascinating, the stories. I interviewed Simon Dowson from Delta Motorsport.
Yes.
And so his episode, when it goes live, will actually be 1 or 2 before yours when yours goes live. And so he and others came out of Reynard, and so from whether it be a business failing or evolving, like the Renault team had to evolve because of regulation changes within the motorsport, comes entrepreneurship and ingenuity, where Flybrid was then born. Yeah, one door shuts and there's always an opportunity to open another door. Yeah. Wow. Okay. Delta is a great company. Simon is a great example of this. Yeah. Very impressive. Yeah, super impressive, and really good podcast interview as well. So everybody make sure you listen to that, as well as clearly the one you're listening to now. You've mentioned other technologies, or other industries. So Flybrid sort of started off in F1 logically, just because of the nature of the people that opened it and launched it. I've also read that you guys are involved in a bit of Le Mans and a few other bits like that. Yeah, because we developed a system for Formula One racing, and we had a customer, a manufacturer-backed Formula One team that we got quite early on, and so we had our first full power course running on the dyno in December 2007, and I think at that time we were the first company worldwide who had the Formula One course running at full power. So we were quite ahead of the development curve for Formula One, and it was because we could focus fully on this task. There were still some politics going on in Formula One. Some people tried to change the rules again so that curse doesn't come in, and there were lots of politics in the background. But we focused on this task, and we had the first system running at full power. But then our customer stopped Formula One racing, so they decided to not continue with their program. So we didn't have a customer anymore, and then the Formula One guys changed the rules to limit the scope and only allow battery-based hybrid systems in Formula One. And so we thought, okay, what can we do with our technology? We always had a plan to also race in Le Mans, because Le Mans racing, you do in one race probably almost the distance that you do in a full Formula One season. Yeah. And one of the big advantages of Flybrids is that they're very robust, that they're very durable, that they work really well in very harsh environments. And so in a Le Mans race, we can show that really well, 24-hour racing. We managed to get a customer, a very small Swiss team. We managed to be the first ever hybrid car to race at the 24 Hours of Le Mans. So that was a big achievement for us as a small company. Yeah. And I was the lead engineer for this project. So personally, it was also a very good episode in my career. Yeah, a great learning piece. Yeah, absolutely. And so that's motorsport, but you mentioned a few minutes ago that obviously there are other sectors and industries that can also benefit from that. Yes. And so I've picked up some of this off the website, and so if you can potentially give me some examples of this, or give our listeners some examples. So I've picked up terms like off-highway. Yeah. So what's that? So off-highway industry, we had some public programs over the years with companies like JCB and Caterpillar, so we can talk about those. Partly supported by the UK government, for example, some great programs with the APC that allow new technologies to be used in different applications. And their typical application would be, for example, an excavator. Because if you imagine an excavator, when the boom of the excavator gets lowered, currently what they're doing is they're actually, so everything is controlled by high pressure hydraulics, and they're actually
revving up the engine to create hydraulic pressure to break that boom from going down.
Yes.
Right? So they're using fuel to lower a 3-ton boom, for example, with a big shovel on the front. What we are doing is, when the boom is going down, we spin up the flywheel. So we have the flywheel, in this case, hydraulically connected to the hydraulic circuit of the excavator. So you can imagine the boom is going down, so it displaces a cylinder, pushes hydraulic fluid down. The hydraulic fluid goes into a pump. The pump spins up, and attached to the pump is a flywheel. So the flywheel spins up, right? And so then when the boom is down, the flywheel is spinning fast. And now when the shovel is in the ground and trying to break out of the ground, you need a lot of power to do that.
Yeah.
And that is when we give the energy back that we have stored from the flywheel. So the energy that is stored by lowering the potential energy of lowering the boom,
gets put back in.
we give back to help the excavator lift the shovel out of the ground. And of course, you can use that in two ways. You can use it so that the engine doesn't need to rev up, so you use less fuel to move that, whatever, 3 tons of earth or whatever. Or you can also add it on top of the engine, and that would help the excavator to break it out faster and to move quicker. And in the off-highway industry, it's of course also about emissions and fuel saving.
Yes.
It's in every industry, but they also have a metric of how many cubic meters per earth they can move per hour, for example.
Okay.
And if you can complete the job faster, that overall gives the end user an operating saving, because you need to pay your staff for less, and you can do things quicker. And if you imagine an excavator, when that is loading a truck, it's like every 20 seconds, it does a full charge and discharge cycle on our flywheel. It's going into the pile of dirt that it needs to move, lifts it up, dumps it into the truck, and it turns around, and it does that every so often. And so we have very high power charge and discharge cycles very frequently. And this is exactly where a flywheel can excel, where you can use the durability and the high power density of a flywheel in the best way.
Yeah, and certainly in a harsh environment, that would definitely be. Just picking up on what you're saying about Le Mans, certainly in excavation, it's lots of dust and rubble and getting whacked. And
they operate these machines in Canada at minus 30 degrees or whatever, and they operate them underground in a mine where it might be 50 degrees. So they need a technology that works in all these different environments. And the flywheel, in the end of the day, it's a simple device. It has a steel hub and it has a carbon fiber ring on the outside. So it's conventional materials. If you can operate a transmission or a gearbox in that environment, you can operate the flywheel hybrid system in that environment. So it's really, really versatile, really flexible, really robust.
What other industries? So I've picked up, I'll read out a few and you can maybe pick up on one. So we've got power generation, commercial vehicles, automotive, which we understand. I think we'll come on to automotive last, actually, because I've got a question about that. And bespoke. So what's a bespoke example?
So bespoke, I would say we class under this applications like the motorsport side of things, but also trains. We have a number of things that are, that when a customer comes to us, sometimes they have very specific requirements. We have standard products that we can offer, especially in the off-highway industry. Our standard product is called 600 series, and that can be used on excavators, on wheel loaders, on things like this. But that product we wouldn't put into a race car because it's optimized for heavy duty environments. So on a race car, you probably make it a bit smaller, a bit lighter. And obviously, if you try to fit something into a race car, you have to make sure it's really small because the space is not very big. And so that tends to be a bespoke solution that we develop just for this customer. And we can do that. That's some of the things that we have done for many, many years.
Okay. Automotive. Something spinning around in my head. Traditional flywheel technology versus electrification of vehicles. And so we're in the Silverstone Technology Cluster in Silverstone Park in Silverstone, where we're surrounded by technology. We had Sally Povaletsky on talking about electric vehicles. We've had a number of other guests in season 1 talking about EVs and autonomous vehicles and the future. Where does flywheel fit into that?
I mean, I certainly have the case that sometimes people come to me and say, okay, why do you still work on flywheels? It seems like that's old technology and everything will turn electric, and then surely you don't need the flywheel anymore. But actually, when you think about it, the characteristics of flywheels and batteries are very, very different. So a battery typically stores much more energy than a flywheel. But typically it gives that energy back at a low power rate. And so a flywheel is very different. We would never design a flywheel that could power a mobile phone, for example.
Sure.
Or that could power a laptop. Or that could drive a car for 200 miles down the road without using the engine. Right? If you have such a requirement, then you're better off with using a battery. But where the flywheels excel is when you have very high charge and discharge powers, and when you need to do that very frequently. And if you try to charge a battery quite quickly, you will heat everything up. So then you need cooling. You might reduce the life if you do that very frequently. And so we have a number of applications where we actually work using the flywheel to help the battery as well, to load level the requirements for the battery. And that provides an opportunity to use some different chemistries in the battery, maybe chemistries that are more optimized towards energy density, which is a direction where a lot of the consumer electronics go to. You want to have a battery in your mobile phone where you maybe don't have to charge it every day. You could use it for longer, right? So in order to do that, you need more energy density to have more energy in the same package. You are not so worried about your mobile phone that it doesn't have enough power, that it takes too long to load an application or something like this. Usually the power is not the issue on how batteries are used nowadays. It's about energy. So a lot of research is going towards energy density. But if you then take such a battery and use it in a dynamically operated vehicle, like a car, for example, then the power becomes more of a factor. And so what the flywheel can offer is that it acts as a load leveler for the battery, that the flywheel takes care of the high power, high frequency loads, and then the battery can be optimized for the average load and the long-term energy provision. And that's quite a nice combination that can be done. So I would say in some applications, flywheels might be seen as a competitor, but actually flywheels cover a very different space than batteries.
Yeah, it should be complementing it.
Exactly, they can be complementary.
Okay, that answers that question and thought I had. Punch Flybrid as a company. So obviously merger and acquisition process sort of 2017, 2018, where presumably your team previously started off as sort of 2-3 people, became sort of 10, 15, 20 plus, I guess, before the merger. Yeah. And then and so what's the number now within sort of Punch Flybrid?
So we actually operate over 2 sites, I would say, because we work very closely together with the team in Strasbourg. Okay. And we moved all our test rigs and our manufacturing machines to Strasbourg. Okay. Because we keep the UK here really as advanced engineering, where we do a lot of the early development, the design. The design, and so that's really the area where we're focusing here in Silverstone. But then in Strasbourg we have the long-term development, the durability testing, and some of the manufacture where really there's clearly a lot of expertise. And so we have some guys working in Strasbourg and some guys working in Silverstone.
And what's the head count at the moment?
So in the UK we only have 9 people. At the moment, but we have about 20 people working for us in Strasbourg on our long-term stuff.
And then Punch as a sort of group company, presumably.
Yeah, the Punch Group itself employs 1,200 people. Okay. So the Punch Group is a big tier 1 automotive supplier, producing about 400,000 transmissions a year, 6-speed and 8-speed transmissions, delivering to a number of big OEM clients. So that's really a big company. And I would say, that's really good for us because for the very first time in the history of the flywheel technology, we now have a route to production. We have a partner or an owner who really can produce the flywheels in as much volume as we want to.
And presumably having a partner like that's tier 1, has enabled you to open doors that potentially you couldn't open before.
Yeah, absolutely. I mean, we are being taken much more seriously by the automotive industry who need a strong partner to take on new technology. They need somebody who they can rely on. And with the Punch Group, they know there's a credible tier 1 supplier who has provided complex transmissions, much more complex than a flywheel hybrid system, to them for many years, and that's really helpful for us.
Okay, Silverstone Technology Cluster. So we've met through actually Gaia Innovation. So we were both at Kingsthorpe College in January 2019, where we attended a speed networking session with about 100 Year 9 students.
Yes.
How did you find that personally?
I think it was fantastic. I was very impressed. I had a lot of good questions from the students. So our flywheel, as I say, it has a steel hub and it has carbon fiber on the outside. And I had one little girl ask me when I brought a flywheel with me to this event, and I put it on the table, and the little girl said, "Is that carbon fiber on the outside?" I was so impressed that she knows, because our carbon fiber doesn't look like normal carbon fiber. How you would see carbon fiber, say, on a race car or on a high-end sports car on the road, it's woven.
Yes.
But the carbon fiber that we use, we created with a filament winding process, and all the fibers are basically in the radial direction of the flywheel, because that's where we need the strength. And the flywheel itself is a very interesting device, because clearly the carbon fiber helps to hold the steel together when we spin up the flywheel very, very quickly. We rotate flywheels with up to 60,000 RPM. So we have on the outside Mach 2, twice the speed of sound on the outside of the flywheel. And the carbon fiber, the strength of the carbon fiber holds the flywheel together. But the really interesting bit is that, so if you would spin up the steel hub on its own, it would fail. But the interesting bit is, if you spin up the carbon fiber part of the flywheel on its own, it would fail as well. Because the carbon fiber part is very strong in the fiber direction, so in the radial direction. But when it spins up, it tries to grow. And in the 90-degree direction, it's just the epoxy material that holds it together. And the strength of the epoxy material is not very strong. And so what we do is we press the carbon fiber onto the steel hub, so that the fibers are always under tension, and it's a symbiotic relationship. Like this, both parts live. The carbon fiber supports the steel supports the carbon fiber, and together you can create a flywheel that's really strong, really power dense, quite energy dense, and very durable. And so the carbon fiber doesn't look like normal carbon fiber, and this little girl, who probably has never seen the flywheel like this before, could identify carbon fiber. I was very impressed.
Well, there we are. And she's potentially one for the company.
Well,
when she's a bit older, maybe some work experience, perhaps. But yeah, the Gaia Innovation Kingsthorpe College Day was excellent. That's obviously where we met. But more so, it's because your firm, Punch Flybrid, and my firm Longhurst, we're member firms of the Silverstone Technology Cluster. Yes. And so can you remember how far back did you guys join the STC as members?
Only as the guys of Punch Flybrid.
Okay.
So only
last year.
Recently, yeah. But obviously we have been linked with the Silverstone Park for a very long time, because as I said, we started in a little office here in the Innovation Center, then moved into our unit just across the car park from the Silverstone Innovation Center. So we are part of
the community. And what's it been like? How important has it been for your business and for you personally to be part of Silverstone Park?
I think every time we mention that we are based in Silverstone, we get a smile from the people. And I think that's really, really powerful. And, it's not only in the motorsport world, where clearly Silverstone is very well known, but also in our off-highway customers. They also follow motorsport, and it helps. It's an icebreaker. It's really, really beneficial to do that. And clearly a lot of the companies that we work with to create these flywheel hybrid systems are based around us. So it's very easy for us to visit a supplier and to get work done here at short notice.
And for those firms listening to the podcast right now who potentially aren't part of the STC, as an example, who might not be based on site also, so they might be an hour away, half an hour away plus, what would you say to them to encourage them to consider joining the STC? Why bother?
Yeah, I think it's a great group of people, a great group of companies that is here, and we can all benefit from each other. So the more we talk about the STC, the more we advertise the strengths of the companies within it, the more opportunities to do business. And I think it's really powerful.
I would agree. I can't think I can add anything else to that. I think that's a very sage piece of bit of advice and reply. Tobias, we're sort of nearly 30 minutes into the interview, so it seems to have flown by, using a flywheel sort of analogy. So let me think about other questions to ask. So we've covered off what Punch Flybrid do, the sectors that you sort of cover. We've spoken a little bit about sort of merger and acquisition and your involvement in it. And clearly the credibility, or the additional credibility, that having a tier 1 owner, sort of business partner, being part of the bigger group, can bring to the firm. We've spoken a little bit about flywheel tech versus electrification, which is interesting. And spoken a bit about the STC and Silverstone Park. So before I get on to the sort of final questions, is there anything that we haven't covered that, whilst I've got you on air, that you'd like to sort of talk about?
Well, I think what's quite important is to always apply critical thinking. And we find that a lot when we deal with customers. So, for example, a lot of the times I think people, when they think about hybrid systems, they automatically think about electric hybrids, battery-based hybrids. But then when we get the people that have an open mind to actually do some calcs and to work out what works for their requirements, they see that there are other ways to do a certain task, and maybe better ways to do it. And so I would say it's important to not always follow the masses, but apply critical thinking to see if it's the right way to go. And I think there's in the industry is a little bit of a worry that with the Dieselgate obviously has driven a very big swing towards battery electric vehicles. Tesla obviously playing a big part of it as well. And I think Tesla has done fantastic work to get everybody to think about how transportation should look like, and what alternatives there are, and how to make a product that maybe wasn't seen as very attractive to be really desirable. But I think, again, from an engineering point of view, I would question if it's the right way to go to have bigger and bigger batteries in the vehicles. Because ultimately it should be about the weight of a device, or the weight of a vehicle. To have a 2.5 ton electric SUV driving around for just one person.
Yeah, silly.
That doesn't seem to be the right way to do it. The things like what Unity does to have a little vehicle that is operated in an urban environment. I can see how that makes a lot of sense to have a battery electric vehicle there. But maybe if you have requirements where you have to drive for longer distances, I think it would be sensible to limit the battery size as much as possible. And companies like Delta Motorsport provide solutions to do range extender options. And I think when you look at it from an engineering point of view, that seems to be very interesting. But obviously, it's more complicated than to just say everything goes electric. And so I think we as an industry, we as engineers, we have a task to educate the general public, to educate politicians, to educate funding bodies, to make sure that we don't head towards a direction where maybe we have an electric version of Dieselgate some point later, when we realize how much energy is involved in making lots of big batteries and recycling them. So that is it's an interesting point. I think it's very difficult to know for sure what the right direction is, but I think it's important for all of us in this industry to apply critical thinking and to combine our discoveries to steer us as a society in the right direction, to make sure that we really do reduce the emissions that transportation provides.
There it is. 2 more questions.
Sure.
This one's a new one that we've introduced into season 2, because we know we've got students listening to the show, perhaps from Kingsthorpe, where we sort of met some, but also the sort of question to support and to help other business owners who might be young, might be entrepreneurial, might be coming out of an employed environment into setting up their own business for one of many reasons. So you're clearly an expert in what you do. I would say, whilst you have a smile on your face, clearly last 10, 15 plus years, Germany through to the UK. If you were to go back to a younger version of Tobias when you were potentially less stressed, a little bit more green, behind the ears, as it were, and at the beginning of your journey, what one bit of advice would you give yourself?
I think it's important to be brave and to believe in your abilities. And especially as a young person, I think it can be very overwhelming to get into the work environment where you obviously work with a lot of experienced people. But I would say in general, follow your heart and be brave and believe in your capabilities. Because if you have the right head screwed on your shoulders, you can solve any difficulties. And we talked about it as part of this podcast. Things won't go smoothly all the time. I had many situations in my life where I thought this is not going well, this is a dead end. And you have to pull yourself up and you have to find these opportunities where you can open the new door when one of the doors shuts. And I think that's advice I would give to every young person, is to believe in themselves and to be brave, that they can solve all issues that come their way.
Love it. I totally agree with that. I think being brave is one of the most important things of any age, whether you're young or old. I think being brave enough to take a step, to knock on the door, to pick up the phone, or to even build your own door.
Yes, absolutely.
So people come and open and knock on it yourself. Yeah. Okay, very last question. Embarrassing mistakes. This is the one where the guest normally sort of wiggles in their chair and thinks, I don't want to admit anything or say anything because no one likes admitting funny or embarrassing mistakes. So is there anything in Tobias's locker, professionally, personally, where you think, God, that was silly or stupid and I've learnt a lesson, or God, anything?
Yeah, I think there are, of course, lots of different things. It's always not so easy to remember them because the human brain is quite good at taking the lesson, but maybe not remembering the embarrassing bit. I have to say, one thing that still sits with me, which is really painful for me, even after many years, is it's actually from school days. So it's a long time ago. But again, I think it was an important lesson that I learned for the rest of my life. Is I was in a math exam, and the teacher had set up some shields so that you don't look at your neighbor's work. But I was stuck in a little bit on one task, and I looked at my neighbor's work, and the teacher saw it, and he crossed out my task, so the thing that I was working on. And he did that, obviously, when you are in such a school environment, everything is quiet, and he said, "Hey, you, what are you doing?" And it was so embarrassing for me. And math was always my best course in school. So I didn't need to look at my neighbor. It was just
stupid decision.
Stupid decision, a bit lazy or
nervous,
whatever.
Worried, panic, adrenaline.
I love maths, and so it was even more embarrassing for me to get called out on a subject that I was always very, very good at. And from this day I said to myself, never ever cheat. It's not worth it. It's just not worth it to do it like this. And you don't need to do it. You have it in yourself. You don't need to cheat. And it's much better if you can get a good result without cheating.
There we go.
It stuck with me. It's, as I say, it's so many years ago.
Powerful.
But and that's why I think it's good that if somebody sees where somebody makes a mistake, to point it out in a nice way. My teacher did it in a nice way. He obviously told me off, and he crossed out my task, but he did it in a respectful way, I would say. So I wasn't mad at the teacher for finding out. I was mad at myself.
Well, he would have realised it was a mistake, right? Certainly if you were very good at maths at the time, which presumably you were, he would have realised it was just a sheer moment of panic and, but embarrassing nevertheless, a mistake that you've learned from, and something I'm sure, if there are any students listening to this or anyone else that's going to be sitting examinations, I mean, I was still sitting exams for my sort of fellowship in my early 30s, and so wouldn't have dreamed to cheat. So really good story, Really good feedback, really good interview. Tobias, thank you so much for coming on. Sure. I now know significantly more about flywheels than I did before the beginning of it, so sure. for my benefit it was wonderful. And hopefully you and I will see each other more, certainly with the Gaia Innovation Schools project, and certainly more around Silverstone Park. So thank you for your time, thank you for coming on, and hopefully we can bring you back on the show in due time.
You're very welcome. Thank you very much, Chris.
Cheers, Tobias. The Inside Silverstone podcast is produced by the team at Longhurst for the benefit of those with a passion for all things tech, engineering and innovation. For more information, please visit longhurst.co.uk/Inside Silverstone, whilst also remembering to give us a 5 out of 5 star rating on iTunes. Please note that neither Chris Broome or Longhurst work for Silverstone Park, Silverstone Circuit or Silverstone Technology Cluster.